So today, what we're going to be learning about is volume. Yesterday, what you did was you definitely did the equation for volume. So you did length times width times height, which is really good because you had to get down the basic skill first. But now we're going to go one step deeper. We're going to actually figure out how to dissect a volume problem. So we're going to look at the problem and then figure out all the different things it's asking for, and then use our skills to make sure we can go into it. So who can read the objective for me?
By the end of this lesson, I will be able to measure volume by counting unit cubes using cubic centimeters, cubic inches, cubic feet, and improvised units, and relate volume to the operation of multiplication and solving real-world and mathematical problems involving volume.
This one, you're going to have to think really hard about which ones were on there earlier. I expect you to get at least 3 of them. One of them we'll talk about. What are some units that can be used to measure volume? Yes, ma'am.
Cubic centimeters.
Good. Cubic centimeters. You can write your name on the board. Good. Cubic centimeters. Come on. Cubic meters. That's a good one. I put that one on the board, but you can definitely put that one up there. Go ahead. Cubic meters. Yep.
Cubic inch.
Cubic inches.
Cubic feet.
Cubic feet. And there's one more that I haven't put up here, but I'm going to. And it's called improvised units. Do you remember that when we were talking the objective that said improvised units? Who knows what that means? That's a really weird word. Who knows what that means? What does improvised units mean? What does improvised units mean? Keelan, what's in here?
Candy.
Candy. Keelan, what if I didn't have centimeter blocks? What if I didn't have inch blocks or feet blocks? But I still wanted to figure out what the possible volume of this could be. What would I have to do? What is one thing I could do? I could fill it with
small object?
I could fill it with objects, right? I could fill it with that many objects and I could count them out. Christian Brooks, you are on fire today. Give yourself 2 points. Excellent. The focus for this lesson really was looking at if we have a volume, how can we break it down into a length, a width, and a height to actually then be able to construct something. So the first day of volume is just figuring out what is volume, talking about what's inside, and then the next day is like learning the actual skill piece of volume. So this is really a good third day lesson for volume, actually teaching them how to apply it. What are 3 ways we can find the volume? One I know you know for sure. Yes to Michael. Good, you can use the formula length times width times height. Excellent, you can write your name on the board. So length times width times height is 1. What are 2 other ways? Oh, you can put a check by your name. Yes. Good, yeah, the base times the height. Good, area times the height. Excellent. So now we have 2 ways to find volume. We need 1 more. You can pack a right rectangular prism with unit cubes. You can use the equation volume equals length times width times height. You can also use the equation volume equals base, which is what Keelan was talking about before. So area times the height. And if you already know how to find the base, you don't have to fill in this part, but if you need a quick reminder, make sure you fill it in. Shania, which one do you want to do?
The first one.
Excellent. So if you're doing the first one, tell me what the length is.
The length is 20 centimeters.
Excellent. What's the width?
10 centimeters.
And what's the height?
30 centimeters.
Excellent. So how am I going to figure out what the volume is?
You have to multiply the length times width times height.
So can you do it in your head?
I don't know. 20.
So what should she be doing for this problem, though?
Multiply 20 times 10 first.
Is?
Get 200.
200. And then she would put in what?
Times 30.
30. But does she need to deal with all those zeros?
Yeah. No.
So what would I have to do to figure this out?
Multiply 3 times 1 times 2.
Good. I multiply 3 times 1 times 2 is?
6.
And then what do I do with all those pesky zeros?
Add them.
Add them on the end. How many are there? I like how you're looking at that computer. 3. So what is it going to be?
600 centimeters.
If I added 3 zeros, what is it going to be?
6,000.
6,000. Excellent job. But just 6,000 centimeters by themselves?
Centimeters cubed.
Centimeters cubed. Excellent. It was really important for me for my students to understand that volume is just an application of multiplication. So having the multiplication skills was, fundamental for my students to be able to actually complete this lesson. So what do I need to do to figure out a missing measurement problem? Who can tell me?
Yeah. Multiply your 2 numbers first and then see what you came up first and then see how much you need after you multiply your 2 numbers.
So we have the length. What else do we have?
The width.
The width. Good. What are we missing?
Height.
I feel like we're always missing the height, though. And then what else do we have? The volume, which is?
960
Just by itself, just inches alone?
cubed.
Oh, inches cubed, okay. Now, what do I have to do to figure this out?
Multiply the length times the width.
Thank you for identifying what they are. Good. You multiply the length times the width. So what are you multiplying? What numbers?
32 times 3.
What's 32 times 3? Oh, look at how I've just written this wrong. What's 32 times 3?
96.
Ooh. Can we give him a round of applause? A round of applause. I feel like he deserves a round of applause for that. That was excellent. Yes, 96. So 96 times whatever this missing height's going to be is going to get me to 960 inches cubed. So how am I going to figure out the height from here? 96 times what is going to get me to 960?
10.
Yeah. How would you know that? How did you know?
Because 96 times 10 is 960.
There you go. It's 960. Excellent job.
This is a giant candy bar, and yes, it is probably Keelan's. The volume of this candy bar is 18 cubic feet. What is a possible length, width, and height of this candy bar?
Keelan, can you imagine if you had a candy bar that was 18 cubic feet though? I was thinking about that as I wrote it. Good job. What do I already have? What has already been given to me in this nice problem? Yes, Mr. Portia?
The volume.
A volume. But what does that mean I'm missing then?
You missing the height, the width. The height, the width, and the length.
I'm missing them all, aren't I? So I'm missing the height. I have no idea what the height is. I have no idea what the width is. And you're right, I also have no idea what the length is. Interesting. So how am I going to figure that out? The one really important thing for people to understand about Common Core is it's just a mindset shift. It's not so different from what we've been doing for years and years, but it's different in terms of thinking about the how you teach it, what you're presenting to students, how deep you're willing to go with them. So what times what times what is going to give me 144?
6 times 2 times 12.
Well, yes, that's absolutely correct. Tell me where you got that. How did you figure that out?
I multiplied 6 times 2, that's 12, and 12 times 12 equals 144.
How did you decide to break that down? Did you start with your 6s? Did you start with your 2s? Start with your 12s? How did you decide to break down 144? You started with your 12s? So in your head, what did 144 start out as?
12 times 12.
Good, I like that. So it started out as 12 times 12 in your head. And then what did you say about that?
I had to break it down to 6.
You had to break it down? So what you chose to break down what?
112.
One of the 12s, good. And one of the 12s became what?
6.
Times?
2.
Perfect. So I have a question. If Christian Brooks told me that the length is 5, the width is 5, the height is 10, and Christian Williams told me that it was 25 times 5 times 2, which one would probably be the better measurements for the pool? Would it be better to have a pool that had a length of 25, a width of 5, and a height of 2? Or would it be better to have a pool that had a length of 5, a width of 5, and a height of 10? Yes, Miss J?
A length of 5, a width of 5, and a height of 10.
Yeah, that's so true. Why would that be better?
Because you wouldn't want your pool to be that short.
Yeah, and what else? What would be the other problem? If the height is 2, what kind of pool is this that has a height of 2? A height of 2 feet. Now, we all know Miss Moore's not that tall, but a height of 2 feet? I mean, is that more of a wading pool? I could definitely toss you in the kiddie pool, but is that going to be fun? No, not at all. Not at all. So what we are doing today for our challenge is this. Now, as usual, what we have to do, I love when you understand problems, and I love it when you're able to do them, but I love it even more when you can actually apply them and make something. So what we are going to do is you're actually going to build me a pool. We need to have a competition to figure out which architect team is going to be able to design the best pool. But there are 2 conditions. Condition 1 is that the pool has to have a volume of 900 inches cubed, meaning that this pool is just going to be a model. We're not going to build the actual pool, A, because Miss Moore doesn't have that much cardboard, and B, because we don't have that much time. So we're going to build a smaller model using inches instead of what we would normally use, which is probably feet or yards. Then your pool, just because I have to be extra difficult, your pool is also going to have to be able to hold water without leaking. The team whose pool is actually 900 inches cubed and doesn't have water leaking out of it is going to be the winner. What we will be doing is this. I'm going to give you all of your materials. Should you just start building off the bat? No, because you're going to have to make a volume of what? 900. So you should probably figure out what first? Your length and your
Width and height.
and your
Height.
so that your volume equals
900.
900. And then what are you probably going to have to do? Measure it. Thank you. And I think it is so important to have this hands-on piece in each lesson that you do. Even if it's something, it doesn't have to be something as big as building a pool. Obviously, that does create a huge mess in your classroom sometimes. But I think this piece about how can I actually physically make or do something with what I'm learning is very big for students because it forces them to actually think about what they can do with that later. This team definitely would tell me what length, width, and height you used.
10 times 10 times 9.
Good. Yours was right. Good. Are you ready? Come on, Keelan. Is it holding the water? Is it leaking?
No.
Oh! Good job. Who can tell me what one thing they did right with theirs and one thing they did wrong with theirs?
We measured the length, width, and height, right?
You did measure it right. Good. Why do you think you measured it right?
Because we used the ruler
You used the ruler, and what else did you do?
and we worked together.
You did work together. I will say you guys worked together really well. What was one thing that was hard?
Taping it up.
Taping it was the hard part. What else was hard?
Like getting the boxes right, the box size
Like the
right.
pieces feeding right? I didn't even realize how hard that part would be. That definitely was the hard part. What I need you to do is start working on your exit ticket. Because while I truly do think most of you really have done a good job and really understand this, what I also think is that I need you to show me. The fifth question on the exit ticket really pushes students' thinking into the lesson we're actually doing tomorrow, which is the two-part problems. The reason I put that at the bottom of the exit ticket is because I want to know who already, based on what they've learned today, can already push themselves in thinking there, and who's still struggling. So if they're still struggling, I have not given them the base foundation yet to then be able to move to that next level. So what I'm going to use those exit tickets for later is to figure out where we can next push ourselves tomorrow. Tomorrow, what you're going to do is we're going to go even one step higher with word problems. Did anybody see number 5 on the exit ticket? You saw how it was 2 parts? Isn't that a little bit different from what we did today? The reason I wanted you to start working on number 5 today is because I wanted you to be able to use your skills, and I was really proud of you, Christian, and really proud of you, Kente, because even though we hadn't gone over that problem before, what I liked was that you were able to use your skills that you had today to figure out how then to solve that problem without ever having seen it. Because I don't think you should have to see every problem to be able to solve it, right? You should be able to use the skills well enough to be able to solve it all by itself. So I was really proud of both of you for doing that today. If you don't know how to do that one, that's okay. We're definitely still gonna go over it, but make sure you think really hard about the tools that you have today to be able to solve it. Make sense? Work hard.
Get smart.
Work hard.
Get smart.
Work hard.
Get smart.
Good job.